The binomial expansion and Pascal's triangle. I'm not going to go too in depth with Pascal's triangle. I'm going to kind of read through this and show you the pattern. One of the most interesting number patterns is called the Pascal's triangle. To build the triangle, start with the number 1 on top. So here's our number 1. Then continue placing numbers below it in a triangular pattern. Each number is 2 numbers above and added together, except for the edges, which are all 1. So these are the edges. Okay? Now, to get 1 plus 1 is going to be adding to 2. All right, so I'm going to go ahead and just erase this because it's going to get kind of messy. To get 1 plus 2, you'll get 3. 2 plus 1, you get 3. Heading down the next one, 1 plus 3 is 4. 3 plus 3 is 6. 1 plus 3 is 4. So if we continue this pattern, another row, could you tell me what this space right here is? Well, that will be 1 plus 4 is 5. And you combine, 4 plus 6 is 10. 6 plus 4 is 10. 1 plus 5 is, or 4 is 5. And then the last one is 1. So you'll see below here, we've gone up to the 7th row. We call this row 1, row 2, all the way here to row 7. Now here is how this is going to help us. If you remember earlier in our class, we took and multiplied this binomial 3 times. And it took us a lot of work. We would first have to multiply these 2 together and simplify it, and then multiply it here. Well, we're going to do a little shortcut instead. It doesn't look like one at first, but as you get in higher degrees here, it will save you time. So here's what we're going to do. We're going to look at the degree of that binomial. It's a degree of 3. So we're going to head over to the appropriate row in just a moment. And I'm going to go ahead and put some placeholders. So I have a placeholder, A, raised to the 3rd. And then the second one is your B, raised to the 0. Plus, just bear with me for a moment, placeholder, A. And now we're going to drop a degree on the A. So now we're on an A squared. And now we're going to increase the B to the 1. And then plus, leave a space, drop a degree, A to the 1st, increase the B to B squared. Plus, leave a space, A, we're going to drop a degree on the A and increase a degree on the B. Now here's where Pascal's triangle comes into play. If you notice, you have 1, 2, 3, 4 coefficients that are missing. These are going to be your coefficients. Look at the degree. Degree is 3. Let's see this first number 3. We're going to go ahead and put those placeholders in. 1, 3, 3, 1. Now we have to just go ahead and simplify that. All right, so how you simplify, I'm just going to go ahead and leave the 1 there. A cubed, and you remember anything raised to the 0 power is also 1. Plus 3a squared b plus 3a b squared plus 1, and then a to the 0, anything raised to the 0 is 1, and then b cubed. All right, let's clean up one more time. 1 times 1 is 1. So that's just a cubed, plus, we're not going to do anything with those next 2 terms, they're already simplified, And our last term, 1 times 1 is 1, and then b cubed. So imagine having to take the time to FOIL that all out, distribute that out, combine like terms, and this is what you would end up with. Let's go ahead and do one more of these. So now we're at a degree of 4. So go ahead and put our placeholder in, and now we're x raised to that 4th degree, and then it's 5 raised to the 0, plus placeholder, drop a degree on the first term, and then increase a term on the second, plus placeholder, drop a degree, increase a degree, plus placeholder, drop a degree, increase a degree, plus placeholder, drop a degree, increase a degree. I want to show you something that I didn't talk about in the last one, so I just want to confuse you a little bit. You'll notice that these two, and these two, and these two, when you add them together, they will always add to this degree. So it's 4. So let's go back a moment. So 3 and 0 is 3. 2 and 1 adds to 3. 1 plus 2 adds to 3. 0 plus 3 adds to 3. Okay. So now we need to go ahead and appropriately correct our row. So remember how many placeholders we have? Missing 5. There's also a 4 here. So we head over to that first spot. That's the row we're going to choose. So we're going to go ahead and put our places in. 1, 4, 6, 4, and 1. All right, now we have some simplifying to do. Be careful here. So we have 1, x to the 4th, and then if you remember, anything raised to the 0 power is 1. Should probably put that 1 there in the front. Plus 4, x to the 3rd, and then 5 to the 1 is 5. Plus 6x squared, 5 times 5 is 25, plus 4x to the 1st, 5 times 5 times 5 is 125, plus 1, x raised to the 0 is 1, and then 5 to the 4th, let's just make sure here, should be 625, but let's make sure. Okay. Yeah, 625. All right, so we're getting down there. So we'll go ahead and say 1 times 1 is still just 1, so we have x to the 4th. 4 times 5 is 20, x cubed. 6 times 25 is 150, then you have x squared. 4 times 125 is 500, x, and then 1 times 1 times 625 is 625. One of the nice things it does, it also puts it in standard form for you.